Okay, good evening, ladies and gentlemen, and welcome to this Black Belt Certification Hackathon, which will be a 3-day session starting from today of 1st of April, and it will continue for 1st and 2nd and 3rd from 7 p.m. to it will be around 9:30, 9:45 p.m. Okay, it depends on the question answer and the doubt clearing, etc. Okay, so welcome you all. And all these sessions basically are meant to push you guys towards the certification examination. Okay, so it's kind of a quick revision of entire course content, so that it will be a refresher for you, and it will be a it will give a confidence to you that yes, you are prepared, you are ready for this. Okay, and we will directly go to some of the what you can say, a little difficult topics in the black belt, and more of the mini tab topics, the practical approaches, etc. Okay, so first of all, let me clarify certain things which are very, very important. The first clarification is, what is the difference between green belt and the black belt? So let me just quickly give a quick update about what is the difference between a green and a black belt. Okay, so green belt is something like, if you remember, uh, you know, I don't know whether you remember yesterday. So yesterday I drew, a tree. Okay, in the live session yesterday. In that, those low hanging fruits. Okay, those low hanging fruits on that tree are nothing but kind of yellow belt projects. Okay, the fruits which are in the middle are called the green belt projects. Okay, where you have to climb a little. Okay, and the fruits which are on the top, which are the most what you can say, precious fruits or most difficult fruits to grab, these are nothing but our black belt projects basically. Now with this analogy, we can understand that simple projects, smaller impacting projects are yellow belt projects. Medium impacting projects, so I can write here medium impact or medium complex project, I would say. Medium complex. And here, black belt projects are high complex projects. All right. In the green belt, moderate level of statistics are required. Moderate stats is basically covered. Here, advanced statistics is used. All right. Here, generally, only one department, only one function is involved. So, generally, the projects which involves only one function in that are generally a green belt projects. So, one function projects are the green belt projects, and black belt projects are multi-function projects. Multi-function projects. Okay. Saving is also, the per annum saving is also lower. Okay, if it is okay, if you have a cost saving or some losses saving, some cost of poor quality saving, so saving is lower comparatively to the black belt. Saving is less and saving is very high. So in some cases, in some companies, I have seen people deciding whether this is a green belt project or the black belt project on the basis of the amount of saving, potential saving of the project. Okay, so saving is very high. In that case, you can consider, see, in the green belt or in the black belt, or let it be from white belt to master black belt, the DMAC framework is absolutely common. The structure is absolutely common. But what changes is, as we go up in the ladder from yellow belt to green belt to green belt to black belt to master black belt, then more and more complex tools we use, more and more advanced statistical tools we start using. Okay, are you clear with this basic fundamental philosophy? What is the difference between green and a black belt? Just give me yes in the chat box, everybody. Just quickly give me a confirmation. This is just a basic philosophy of what is, green and what is black. Just give me yes quickly. in the chat? Am I audible, by the way? Am I audible to you? Is it clearly audible? Yes, no? Just a second. Okay. Yeah, the chat was not opened. All right. So my team has just made that correction. Okay. Thank you very much. I thought I was speaking and I was not audible and you guys are completely blank or what? Okay. Now it has got sorted. My team has made the changes. Okay. Thank you, Sohil ji, for this change. Okay. Okay. So finally I got it. Your confirmation that the difference between the green belt and the black belt. Okay. So now, for the new members, okay, hackathon is basically a stage where, see, we have seen a lot of people taking admission after yellow belt. They pump up and they take the admission in the green belt, black belt, but then the life takes over, right? So they sometimes they study, sometimes they attend a live session, but giving the examination requires a preparation, requires a little bit of courage, because uh, it has been a long time since we have given the examination, for certification, etc. So for those kinds of feelings, okay, we just overcome in the hackathon and we kind of push you guys gently towards the completion of the course as well as certification examination. Okay, that's the entire journey of it. Okay, so let's in the black belt, no, even though some of you would be very new, okay, that's what even yesterday also I mentioned, that even though you are very new, come and attend the session, you will learn a lot of things. Even though you are a yellow belt certified only, okay, doesn't matter. Just sit with an open mind. Even if you don't, you haven't gone through the green belt content and the black belt content, just sit with the open mind. Some of the things you may not understand, don't worry, ask me, I will explain you again. Okay, but predominantly this session is built for the people who are green belt certified and who have been through the black belt course. Okay, and now they are ready for examination. How many of you are like that? Just type me in the chat box. How many of you are like that? You are green belt certified already and you have been through the black belt course curriculum as well and you are ready for the examination. Okay, yes, Ranjan ji is there. Who else? Okay, Divakar ji is there. Dhanush Babu is there. Dhanush Bablu is there. Fantastic. Saumi Chakrabarti is there. Fantastic. Super. So these people, and of course, people are still joining in because today is a working day, 1st of April, and people might be traveling and would be joining in as well. Okay. So these are the people who are basically, they will go through this course content quickly and they will go for the examination. Okay. And in this, we will go for a lot of Minitab exercises. Okay. So let's begin the Minitab exercises. Can you open the Minitab worksheet, blank worksheet? We will start doing some interesting exercises. Even new guys also will enjoy this. Okay. Chalo, open this Minitab worksheet. Let's open the Minitab worksheet quickly. Let me also open. Oops, what happened? Okay, so here we go. So here is my blank Minitab worksheet. Okay, open any blank Minitab worksheet. Just type done in the chat box if you have done, if you have opened. See, if you are not traveling, you have laptop, desktop in front of you with Minitab, please go ahead. Okay, just done, type in done in the chat box. Okay, done. Very good. Other people? Yes, very nice. Superb, superb. Chalo, let's do one thing. Let's generate some data set. Okay. Go to calc. Everybody follow this path. Go to calc. You can find out in this, in the first line over here, file data, file edit data and calc. Calc is a calculator. Just click on calc, random data normal. Just follow this path, please. Calc, random data normal. All right. Calc, random data normal. Once you click on that, calc random data normal, once you click on that, this window will appear. Okay. Now here it is asking that number of rows of data to generate. That means the software is asking how many rows you want to generate, how many line items you want to generate. Let's type 5. I want to generate 5 line items. All right. Now it will ask you store in column. So here we will type C1. Everybody just type C1. C1 is this column, the first column. C1 is column number 1. Okay. C1 is column number 1. All right. And don't do anything. Let it be like this, whatever it has shown. Just put 5 and C1 and click on OK. So it has generated some 5 random numbers. It has generated 5 random numbers. Everybody got this? Just type yes in the chat box. What we have done, I'll just repeat, go to calc, random data, normal. Okay. And I've selected 5 numbers and C1 column and click on OK. Okay, done. Now what you can do is do the same thing again. Now what we will do, instead of 5, we will select 50. Okay, can we just do that? Okay, now we don't have to go again to the calc, random, etc. We can directly go to the last, edit last dialog box. Look at this. Look at my cursor here. It shows edit last dialog box, which says Control E, or the short key is Control E. If you press Control E from your keyboard, Control E, you will come directly to this. Now, instead of 5, just select 50, 50. Now we are generating 50 data points and we will store it in column number 2, C2, and click on OK. So there are 50 data point generated. Everybody with me? Just type yes in the chat box. सब मेरे साथ है? First we generated 5, now we have generated 50. Again do the same thing. Now we will generate 5,000. Let's put 5,000 data points and we will generate it in C3 column. And say OK. So we have got in C3 column, we will have 5,000 data points. Okay. Now let's do one thing. Now we will create, everybody done? C1 5 numbers, C2 50 numbers, C3 5,000 numbers. And we have generated randomly. We don't know which numbers are they. Create. Done. Everybody just give me confirmation. Anybody behind who is doing this along with me? So we will wait for that person. Okay. Especially the new people. If you are not well versed with Minitab, we'll wait for you. Okay. Very good. Super. Now, once we will do that, let's go for histogram creation. Go to graph. And the 5th option from the top is called histogram. Okay, go to graph, histogram. Everybody just click on that. This window will appear. Here we are selecting with fit on the first row, right hand side with fit, and say OK. Now what we will do is we will select C1, we will select C2, and we will select C3 and say OK. And we have got all the 3 histograms getting created. Everybody got this? Just type yes in the chat box. Let me reduce them. Got it? All the 3. You can select all the 3 together. Wow. So I'm just arranging it in front of you. Done, everybody? Now these are 3 histograms. Now if you observe very closely, you get this. If you observe very closely, this, yeah, I'll repeat again. I'll repeat again. Okay. Now, have you generated data? Have you generated data? Tamil Rasanji, have you generated data? Just give me yes or no in the chat box so that I can repeat from there. Yes, okay. You have generated all the three data points, right? 5, 50, and 5,000, correct? Now what we do is go to graph and go to the fourth option called histogram. Go to graph and the fourth option is histogram. Fifth option, okay, marginal plot ke niche. Click on that. Select with fit. Select with fit. Click on OK. And here in this column, okay, just select all the three variables. C1, double click on C1, double click on C2, and double click on C3. That's it. And click on OK. And you will get all the three diagrams in front of you. Then you can just play around this and arrange them in front of you. Clear? Just give me yes. Once you are done, let me just know it in the chat. Okay. Yeah, all the other people, what is your observation? Type in the chat box. What are you observing? Yeah, what are you observing? Type in the chat box. Yes, what is your observation on all these three graphs right now in front of you? Now, your graph might be a little different than mine because your data set is differently generated data set. Correct? Now, let's look at my graphs. Okay. Let me ask you this question. More data, more normal graphs. Very good. Very good observation. Okay. Look at this. If you see this graph, okay, this is called histogram. What is histogram? Histo meaning historical data and gram meaning graph. Gram meaning graph, right? So here on the y-axis, there are frequencies. Okay. So here, for example, in this is only one frequency data is there in this column. Okay. Let me just change the color. If you see here in this graph, this one, only one frequency is there because there are only 5 data points. Okay. Here there are 2 frequencies. Again, here one frequency and one frequency. So there are 5 data points. Okay. 1, 2, 1, 1. These are 5 data points. But it is, if you see here, majorly this is kind of a skewed distribution. Of course, there is one data point on this side, but more or less this is kind of a skewed distribution. Once I increase the sample size here, it has started taking a little bit of normal distribution. But when I increase the sample size very high, it has taken kind of a perfect normal distribution. Are you understanding this? Everybody, are you understanding? So this is normal distribution. This is kind of non-normal distribution. How many of you got this? Just type yes in the chat box. Can you see when we have 5 data points, the distribution is not normal, not symmetrical. When I increase it to 50, it is taking some shape. It has become normal distribution. When I increase it to 5,000, it became perfectly normal distribution. And this phenomena, it's called as central limit theorem. Write this down. Central limit theorem. Or we call it as CLT. What CLT talks about? CLT says, whenever you come across non-normal distribution, increase the sample size, it will naturally takes the shape of normal distribution. I'm talking about a continuous data. Everybody is clear about continuous and discrete data? Just type yes or no in the chat box. Are you clear about continuous and discrete? The new people may not be aware of this, which we cover in great details in the green belt level. Okay. So in green belt level, you will understand what is continuous, what is discrete. Here, this is where the discrete data, the continuous data will be more prominent here. Whenever we have continuous data, increase the sample size, you will get the normal distribution naturally. And this is called central limit theorem. Are you clear with this theorem? So whenever there is a non-normal distribution you observe, just increase the sample size and you will get a normal distribution according to CLT. Just type yes in the chat box if you have understood this central limit theorem. So what we have done, we have understood how to generate data, how to make histograms, and what is central limit theorem in this small exercise. Clear? Just type yes in the chat box. Clear? Now see, this is the black belt hackathon, right? Green belt and the black belt. Green belt and the black belt define phase is exactly same. In the black belt also, we use project. What are the tools do we use in the define phase? Type in the chat box. Type in the chat box. What are the different tools we use in define phase? Everybody, type in the chat box. Chalo. Because a lot of people are going to go for the examination, so I want your preparedness for this. Okay, fantastic. Project charter, very good. SciPoc, very nice. SciPoc is there. Project charter, SciPoc. What else? Cano model, very good. What else? Super. So project identification, super, very nice. So internal, external project identification, super, very good. What else? और क्या क्या है? CTQ, perfect. And communication plan, right? Stakeholder analysis. Correct. All these RACI metrics, very good. Okay. So all the new members, all these topics which they have listed, no? Yes. So voice of customer, voice of business, voice of process, everything comes in a define phase. So all these topics you will understand in the define phase of the green belt itself. Okay. The same are replicated in the black belt. So in the black belt, I'm not covering all these topics. In the green belt hackathon, we cover this in details. Okay. Yellow belt में भी हम लोग project charter वगैरह करते हैं. So I'm not taking anything from the green belt. I'm directly starting from the major phase. Okay. Because in major phase, there are a lot of tools which we don't use in green belt. We use in the black belt level. Are you clear? So the bottom line is define, green belt and the black belt, define phase is all the tools are common. Are you clear? Just give me yes in the chat box. Clear hai? Give me yes. Super clear. Understood. Especially the new people. Very good. Very good. Now let's do, in the same data, let's say in the same data. Okay. So we have generated this data, right? Now there is a tool called measurements. Now in the measure phase, what is the main objective of measure phase? The main objective of measure phase is to collect the data, extract the information out of the data. So what do we do? First, we collect the data. I'm talking about measure phase. So in the measure phase, what we do is we collect the data, right? And then we extract information out of the data. Okay, with the help of Minitab, right? So we do histogram, we do Pareto analysis, we do box plot analysis, we do control charts, we do time series plots, we do process capability analysis. So all these things we do when we collect the data and after that. But before we collect the data, there is one very important thing we do, and that it's called as MSA. Everybody type MSA in the chat box. Yes, very good. Converting to statistical. We do MSA. Everybody please type MSA. MSA meaning, what is the meaning of MSA? What is the full form of MSA? All the black belt students, can you just type MSA ka full form? What is the full form of MSA? Just type yes. क्या है MSA का full form? हाँ, fantastic. It's measurement system analysis. All the new members, for you, MSA meaning measurement system analysis. Okay. Meaning, before we collect the data, we check whether any variation is there because of the measurement system itself. Now, how do you remember 6 M's, right? Man, machine, method, material, measurement, mother nature and measurement. There is one category called measurement. What is that measurement category? That means there is some variation coming from measurement. Let's say you have a weighing scale. That weighing scale's load cell is not proper. It is not calibrated. So it will not give you the accurate result. There will be the variation in the result. Yes or no? So it is called measurement induced variation. What is that? Measurement induced variation. So with the help of MSA, we quantify how much percentage variation is induced because of measurement system. In the total variation, see, in Six Sigma, we reduce variation. Everybody look at me, very important. In Six Sigma, we reduce the variation and reduce the rejection. Yes or no? Everybody knows this philosophy. In the first, even in yellow belt also, I mentioned this. This is the variation. Okay. And this is the specification limit, right? Whatever goes beyond specification is a defect or rejection. So in Six Sigma, what we do, we reduce the variation and bring the process to the center. Everybody knows this basics. Anybody does not know, just let me know in the chat box. Yes. In Six Sigma, we reduce the variation by, so then we ask the question, what are the different reasons? So man, machine, method, mother nature, material, etc., etc. We find out the reasons, out of which measurement also plays a crucial role. And there are a lot of measurement, measuring devices we use in our process. Now tell me in the chat box, which measuring devices do you use in your process? Type in the chat box. Everybody, type in the chat box. Which kind of measurement devices? It can be a software. It can be a vernier caliper. It can be a weighing scale. It can be a screw gauge. It can be a thermometer. It can be a speedometer. It can be a voltmeter, ammeter. Yes. Level indicator, vernier, micrometer, softwares. Fantastic. Analytical weighing balances. Absolutely right. All these are the weighing system, the measurement systems. Now, measurement system also can create variation, and that variation can be quantified with the help of MSA. Are you clear? So how much variation is induced because of measurement system? It's called as MSA. Are you clear with the definition? Just give me yes in the chat box. It is a quantification of the variation induced because of the measurement system. Clear hai? Basic funda clear? Just give me yes in the chat box. Clear hai? So when we say MSA, which is measurement system analysis, if we have continuous data, then we go for gauge R and R. And if we have attribute data, which is the discrete data, okay, which is yes, no, pass, fail, male, female kind of attribute data, then we go for attribute agreement analysis AAA. So in MSA, there are two parts. If you have continuous data, let's say temperature is a continuous data, pressure is a continuous data. If you have, the length, width, height, so that kind of a continuous data you have, then we use gauge R and R, repeatability and reproducibility. You want to measure the diameter. It's a continuous data. It is expressed in the decimals. It is continuous data. So we use gauge R and R. And if we have the attribute data, like let's say, for example, in a bank, for example, in a bank, there is a credit manager's credit department is there. And if I give the file of the person, and I will check whether one credit manager will say, I accept the file, other credit manager will say, I reject the file. So whenever we have that kind of data, that is called attribute data. In that case, we do attribute agreement analysis. Are you clear with this fundamental of MSA? Just type yes in the chat box. So we will go deeper into the practical aspects of MSA, how it is done with the help of Minitab. Clear hai? So MSA has got two branches, continuous data, gauge R and R, gauge repeatability and reproducibility. And when we say attribute data, when we go for AAA, gauge GRR stand for gauge R and gauge repeatability and reproducibility. Gauge repeatability and reproducibility. We will do it practically. I will explain you. AAA is attribute agreement analysis. ओके, प्रैक्टिकली करके देखते हैं तो आपको ज्यादा क्लियरली समझ में आएगा. practically matlab mini tab pe upar click. Now we see we cannot perform it right now. You guys are traveling, you guys are sitting there, okay? Otherwise, I would have done it, in front of you with the help of vernier caliper, but I don't have that equipment right now. But anyway, I will do this with data. Okay, let's do one thing. Let's create, okay, before that, let me clarify some of the fundamental things. See, this measurement system analysis, no? There is a global body. Basically, it is originated from automotive industry. Okay, ऑटोमोटिव इंडस्ट्री में ये बहुत ही ज्यादा स्ट्रिंजेंटली फॉलो होता है. सो देर इज अ बॉडी कॉल्ड AIAG, विच इज Automotive Industry Action Group, which is a US based body, and there is a body from Germany which is called VDA. VDA, there is a German name for that. This is a German body. So see, we have automotive giants, some part of in US, some part in Germany. Okay, German giants are just like BMW and Mercedes, or they're German giants. And if you go to US companies, then you have Chevrolet, you have Ford, and you have the other the Chrysler, and all these big companies are from US. So US and Germany, these are two major bodies, and they basically create this the MSA, measurement system analysis thing. So according to them, okay, so what is gauge R&R? No, you were asking about gauge R&R. So gauge meaning the equipment, okay, which you are using, and R&R meaning repeatability. Okay, repeatability, and second is reproducibility. Everybody make a note of this. Okay, what is repeatability? They understand this. Huh? Let's say this is the pen, and I want to measure the diameter of the pen. Understand this? Okay. So if the same sample with the same equipment, let's say I want to measure it with vernier caliper, for example, okay, and the same equipment, okay, and the same person, let's say if I measure it multiple times, understand this. Let's say I take the pen, I take the vernier caliper, I measure this, and I measure it first time, I write down the result. I measure it second time, I write down the result. I measure it third time, I write down the result. But I will do it randomly, not in sequence. Huh? Understand this? I will do it randomly. Okay, I will take 3 readings. If all the 3 readings are exactly equal, then it is called as repeatability. My ability to repeat, it's called repeatability. My ability to repeat the same reading again and again, it's called repeatability. Are you clear? With the same vernier caliper, with the same pen, which is the article or the sample, I will take the diameter 3 times. If the same 3 readings are there, then it is called repeatability. Are you clear with this? Just type yes in the chat box. Just give me yes. See, attribute agreement analysis be same hai. If the same loan file is given to the, let's say I am the credit manager, the same file is given to me. I'm saying accept the file, accept the file, accept the file all the 3 times. That means I'm repeatable with my readings. Are you clear? Same thing. Okay, it is for gauge R&R as well as attribute agreement analysis. All these things are same. Okay. Now coming back to reproducibility. What is reproducibility? So repeatability is same person repeating the same reading. Okay. Ability to repeat, that is called repeatability. What is reproducibility? Same sample, same equipment, same vernier caliper. Okay. But different person. Okay. Same point of sample size. Exactly. So let's say, for example, I'll give you how many samples have to be taken. So here, the same pen is given with the same equipment, same pen and the same vernier is given. Now, Dhiresh has done it. Let's say it is given to Suresh. Now, if Suresh also delivers the same result as Dhiresh, that is called reproducibility. Yes, same location, exactly. Then only it will make sense. Otherwise, there will be variation. So we have to define which location you have to take the reading. Okay. Yes. Are you clear? So repeatability meaning same sample, same equipment, same person taking the reading. Reproducibility meaning same sample, same equipment, different people matching the same reading. It's called reproducibility. Are you clear with the just type yes in the chat box? And how do you remember? Because this is kind of a tongue twister, kind of a, confusing. What is repeatability? What is reproducibility? It's very simple. How do I remember? Okay. I remember like this. To reproduce, okay, as in a human species, to reproduce, we want two people, right? A male and a female. Understand this? To reproduce, we want two people. So that way you can remember. For reproducibility, we want different people. Are you clear? This way you can remember this. Clear hai everybody? This is called simple GRR ka explanation, gauge R and R ka. And according to AIAG guideline, AIAG manuals mein, okay, according to their guidelines, what they basically suggest is this, okay. They suggest minimum 10 samples. So the minimum 10 samples. Yeah, VDA is the German counterpart of AIAG. AIAG is a US counterpart. Okay, American companies का group है, automotive industry action group, and VDA is a German automotive का group है. Okay, and they recently have published this standards together. Earlier, AIAG standard was different, German standard was different. Okay, now they have started publishing the, it is true globalization has started happening. Anyway, coming back to this. So according to these AIAG and VDA guidelines, you have to take 10 samples like that. For example, 10 pens you have to take. Okay. And you have to take every pen, let's say every sample you have to take 3 times. So there will be 3 trials for every pen. So everybody will take the same pen and measure it thrice. And you have to take 3 people as well, which we call them as appraisals. Appraisers meaning the quality checking people. Okay. So you have 10 samples multiplied by 3 trials. Every sample will be tested thrice. And there will be 3 people who will be doing that. So 10 into 3 into 3 is equal to total 90 data points you will have. You will collect total 90 data points, and then you will put that into the software, and software will analyze those data points for you. This is how, what is the next step I am going to explain you. Everybody's clear yahan tak? What is MSA? What are the 2 parts? If continuous data, gauge R&R, discrete data, AAA. Then it is from automotive industry, AIAG and VDA. Together they, supply this guidelines. According to guidelines, what is repeatability, what is reproducibility? And then 10 sample, 3 trials, 3 appraisals. Clear? Now let's, with the same thing, we will create this. How do we create, the data collection worksheet, okay, in the AAA, etc. Gauge R&R, okay. How do we do that? Go to stat, go to quality tools, go to gauge study, and create gauge R&R study worksheet. Everybody just follow this. Stat, quality tools, gauge study, gauge R&R. Gauge study meaning gauge R&R study. In that, the second option is create gauge R&R study worksheet. Now, we are preparing a worksheet to collect the data. We are preparing a worksheet to collect the data into that. Okay. Stat, quality tools, gauge R&R. Just click on that. Everybody with me? Stat, quality tools, gauge R&R, create gauge R&R study worksheet. Click on that. This will open. Now, if you remember, we have 3 things, okay? Number of samples, 10. Number of appraisers or operators are 3. And number of trials or replicates, we call it as 3 as well, okay? So same thing you have to do. So number of parts meaning number of samples, 10. If it is something else, you have to change it to 10, okay? Then number of operators, you have to put 3. If you want to give the name of those people, let's say Nilesh, Suresh, and let's say Ganesh. I'm just giving some random names, okay? Nilesh, Suresh, Ganesh. All right. Now, number of replicates meaning number of trials, so you have to increase to 3. All right. So here, I'm just quickly So number of parts are nothing but number of samples, which is 10. Number of people is 3. We have given the names. Okay. And then number of trials, which is replicates, meaning the trials. Replicates mean repetition. Okay. So we are taking 3 trials. Okay. Just once it is done, just type done in the chat box. So once it is done, then you click on OK. And then you will find a table which will be created like this. Have you got this table created? Just type yes in the chat box. So here in this, it has got the run order. Run order meaning with this order, you have to run this because it has been randomized. See, when we are repeating the readings, so we don't repeat the reading in sequence. Understand this. We randomize it. That person does not know what is sample number 1, what is sample number 10, what is sample number 7. So that is actually masked. It is not clear to them. Okay. So first of all, let's say Nilesh example. Okay. And here it will be, let's say we are measuring the diameter. So I will write here diameter. Okay. Let's say Nilesh will have part number 9. In this case, Nilesh will have part number 9. All right. Now Nilesh will measure, let's say 10.1. Then Nilesh will have part number 7 and Nilesh does not know which part is coming. Then Nilesh will measure 10.2. 6th part will come. He will measure 9.8, etc. So randomly things will come to Nilesh and Nilesh will keep on taking the readings and monitoring it. After that, Suresh will come. Suresh will also do that. Suresh's number will be completely different. Only the person who is facilitating this, he is the person who is measuring basically and giving those. His work is without their knowledge, without the appraiser's knowledge, they have to read this. Okay. And similarly, all the 90 data points, you have to take the readings. Okay. You can see here, all the 90 data points readings have to be taken. Clear, everybody? You can see. Yeah. Just type yes in the chat box if you're clear on this. Everybody got it? सबने बनाया? हाँ. Okay, you can see here 90 data points have been created. Okay. Again, parts, please. Parts meaning, okay. Part meaning the random. See, understand this. Okay. For example, let me go back to the edit last dialog box. Okay. Now understand this. Edit last dialog. If I go back to the edit last dialog box, okay. Now I will come back to this. I go to option. In the option, now remember this, in the option, there is by default randomize runs within operator has been selected. Okay. Now understand this. If I just say do not randomize, if I say do not randomize and say okay and okay. All right. Let's go back to the worksheet. Now, can you see here? The run order and the part order is exactly same. That means what? The first part will go to the Nilesh, first part to Suresh, first part to Ganesh. Then second part to Nilesh, second part to Suresh. So you can randomize it accordingly. So the run order meaning what you have to basically, what is the sequence, and part meaning we have 10 pens, no? So part 1 meaning first pen, part 2 meaning second pen, part 3 meaning third pen, part meaning the pen or that whatever sample you have. Clear, everybody? Yes. So you can randomize and, you can, but randomization is expected because we don't want any bias to creep in. Clear, hai? Now, let me just share with you. Now, let's say this is how we have created the worksheet. Now, what we will do? Let me share with you a already made Minitab worksheet where the data is already available. Okay, so that we can analyze that data. All right, so I'm just sharing that file with you. The file's name is gauge R and R. Okay, example, gauge R and R example. Can you just open that file? I've just shared that file in the chat. Okay, the name of the file is gauge R and R example. Okay, the same file. I've just shared it twice. You can just click on that, it will open it. Once you have opened, let me know in the chat box. Okay, ओपन होने के बाद आप चैट बॉक्स में कंफर्म करिए ओपन करके. डन, ओपन्ड. Super. Yeah, once you have opened, let me know. The file which I have shared, that file is having similar kind of readings where the sample is there, operator is there, Yogesh, Manish, and Vijay. There are three operators, and we have already have taken the readings for this. Okay, clear? Now, how do we analyze it? So we have understood how to create the worksheet to collect the data. Now this is a worksheet where we have already fed the data. Now this is a step to analyze it. Everybody opened it. Just give me yes, no in the chat box quickly. Opened, yes, no, done. Very good, super. हाँ, चलो. So आगे बढ़ते हैं. So this is how the data will look like. So what we do now? Go to Stat, Quality Tools, Gauge Study, and you have to select crossed. Gauge R and R study in bracket crossed. Select that. Done. Now, see, there are three options you will see. One is gauge R and R study crossed, gauge R and R study nested, and gauge R and R study expanded. Okay, crossed, nested, expanded. What does it mean? Crossed meaning, let's understand this. Okay, let's try to understand this. Cross meaning what? Now there are 10 samples like this. Okay, and there are three operators. Correct? And all the operators are checking all the samples. If I draw a schematic diagram, it will look like this. Correct? So all the operators are basically checking all the samples. So the diagram will look like this. And this is what the crossed is. Okay. It is crossing each other. That's why it is called crossed. Okay. What is nested? Nested, when do we use nested? In some cases, in some cases, we, once the sample is used, that sample is deformed. For example, let me give you example of it. Okay, let's say tensile strength. How many of you are mechanical engineers here? Mechanical engineers hai koi yahan pe? Anybody in the room who is mechanical background, mechanical engineer? Okay, Devdas ji hai, very good. Who else? Okay, only one. All right, just for our understanding. Okay, let's say I want to check the tensile strength of, let's say this is the metal, and I want to check the tensile strength of the metal. So there is a machine on which we will basically, fix this basically metal piece, and with the help of hydraulics, it will pull. Okay, pull that article or metal piece in both direction. And at what point it basically deforms, that is the strength, the tensile strength is measured. Okay, understand this. Now what happens once I test this? Once I test this sample is deformed. No, this sample cannot be used again. Okay, this is called destructive testing. So tensile testing is called destructive because that sample gets destructed. It cannot be used again. In that case, we use nested design. Why it is called nested design? Because one person uses one sample, the same sample cannot be used again. Are you understanding? So it is like, one person only use various samples, and there is no crossing over. There is no crossing because the same sample is not used by other. That's why it's called nested. Anyways, and what is expanded? So again, crossed meaning people using the same sample for each other. Nested meaning with the destructive testing, the same sample cannot be used again. Go for nested design. And expanded meaning, let's say you are measuring, let's say along with diameter, you are measuring length as well. So there you are measuring two or more parameters. Then you go for expanded gauge R&R. Are you clear? Just type yes in the chat box. Clear hai ye? Super clear, everybody? Okay, so gauge study में crossed meaning for we are using the same sample for all the people. Nested meaning destructive sampling में nested को select करना है, and expanded meaning if you are using multiple parameters. Okay, not only one parameter. Okay, that will be nested. Okay, I'll share the file again. This is the file for you. The name is gauge R and R. By the way, this recording which is being done, this recording will be kept in the Black Belt Hackathon folder. Okay, not in our regular, what you can say, our masterclass archive. Okay, in our regular Monday as well as Saturday sessions, recording is kept in the masterclass archive, especially for the new people. This recording will be kept in the Black Belt Hackathon folder. Below the recording, you will find all the files. Whichever file I'm sharing, everything you will find below the recording. Okay, coming back to this. Go to stat, quality tools, gauge study, crossed. If you check this, select part number में select sample, operator में select operator, and measurement data में select the size, which is the data actually. Okay. And method of analysis, you can select ANOVA, you can select gauge R, X bar R. So I've selected X bar R. You can select both as well, meaning you can select either of this, but I'm selecting X bar R as of now. Okay. In the options, if you go to options, everybody just take a look at this. Part number meaning sample. In the sample column, you have the number of the parts, right? Number 1, number 2, number 3. ऑपरेटर का नेम कौन से कॉलम में है? C2 कॉलम में, ऑपरेटर नंबर नेम के कॉलम में. एंड मेजरमेंट डेटा किस में है? C3 कॉलम में, साइज कॉलम में. जस्ट सिलेक्ट अकॉर्डिंगली. ओके, एक्स बार आर को सिलेक्ट कर गो टू ऑप्शन and make sure upper and lower specification limit, you select one here. Just put one here. What does it mean? Let me explain you. In this particular case, there is a specification limit, upper and lower specification limits difference is 1 mm. Okay. That means in the nutshell, just for your understanding, if this is a data set, okay, the mean is maybe around 2.5 mm. So upper specification and lower specification is lower specification and upper specification. Let's say this is target. So lower specification will be 2 mm and upper will be 3 mm. So what is the difference between these two is 1 mm. Okay, clear? That's what we are writing it over there. Right? So go to option and upper minus lower specification is 1 and click on OK and click on OK. Yeah, everybody got this? Just give me yes in the chat box. सबको मिला ये? Just give me yes, no. मिला? Very good. Super. Super duper, guys. Now, quickly, let me just talk about this. Now, this, let's not get into the each and everything, but what is expected? Okay, understand this. Very important thing is gauge R&R and part to part. Now, let me explain you what is gauge R&R and what is part to part. What is part to part meaning? Actual process variation. actual process variation. What is actual process variation? Variation coming from machine, material, okay, method, or maybe man. All these things are actual process variation causes. And what is gauge R&R? The variation caused by measurement. Are you clear? So whenever we do fishbone, whatever measurement variation is there, remember what is MSA? It is quantification of measure variation induced because of measurement system. In the total variation, how much variation is because of measurement system? That quantification is done in this MSA, right? And GRR is one of the MSA only, correct? So here what it is showing that actual is very high, and measurement variation is very low. And that is what is desired situation. We want measurement system variation to be very low and actual variation to be very high. Are you understanding this? Just type yes in the chat box. Actual variation because of man, machine, material, method, etc. So that we can focus on them. We can focus on man, machine, method, material, and mother nature and other causes. Clear? Just type yes in the chat box. Have you understood this? The takeaway is actual variation is very high and variation induced because of measurement is very low, which is desired. Let me give you example. How many of you are in the weight loss program right now? Just type me in the chat box. How many of you are in the gym, dieting, yoga, exercises? Just type me in the chat box. Just to give a reasonable example on this. Nobody in the room right now doing this? Wow. What a health conscious group I have here. Okay. Now, ये बोलने के बाद कुछ लोग बोल रहे हैं हाँ 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 I'm there. Okay, it means measurement system is fine, but other factors are not fine. Very good. Exactly. Okay, now let me give the example. Now let's say you are in the weight reduction program. Your weight is 90 kg, example, and you want to reduce it to 80 kg. Now, what are the factors? Your stress level, your diet, your exercise schedule, your metabolism, lot of things will impact, yes or no? Apart from that, there is something called your weighing scale. Understand this? Now you have a weighing scale which is a bad weighing scale, which is a faulty weighing scale, which has got a load cell problem. It does not give the reading properly. Sometimes it gives 95 kg, sometimes it gives 82 kg. There is huge variation. Now you are doing the diet, you are doing yoga, you are doing everything, but your your weight, instead of going down, is increasing. Now what statistics is saying to you right now in MSA? Before you jump into your all the process parameters like this, before you attack man, machine, method, material, etc., first check the weighing scale, which is your measurement system. जहां से आप डेटा कलेक्ट कर रहे हो, from where you are collecting the data, check the source. Is there any variation coming from the measurement system? So MSA quantifies how much variation is coming from the measurement system. If it is less, then you are relaxed and you can focus on the other parameters. You can focus on your diet, you are focused on your exercises, you are focused on your metabolism and your sleep and other factors. But if your weighing scale itself is giving huge variation, you need to first fix your measurement system and then you need to fix the other parameters. Are you clear now with this analogy? Just type yes in the chat box. The data, wherever your data we are taking from that system also can induce variation. And that is what we are fixing here. Clear? So desired state is part to part has to be very high, the skyscraper, and gauge R&R, the height of the bar should be very low. And this is what is happening. Okay. Now here you have got control charts, X bar and R control chart. R stands for range and X bar stands for average. Okay. So they have generated this X bar R chart. Here, the X bar R chart is a little different, especially the X bar chart. Okay. So R chart is showing that it is fairly under control. Only this one data point needs some investigation. Okay. This data point might have some recording error or something like that. That needs to be investigated. But X bar chart has got something extraordinary. Okay. In this gauge R and R, X bar chart here is, okay. If you remember our control chart, in our control chart, of course, we are going to touch upon control chart in the last day, okay, in the final day. So in the control charts, whichever data it is falling in the control limits, right? This is X bar, which is the average. This is upper control limit and the lower control limit. If the process is flowing within the control limit, that is said to be a stable process. Yes or no, everybody? Everybody remember this? In the stability check, in the control charts, we study this, correct? Any process flows between control limits, it's called a stable process. Yes? But in this gauge R and R, it is exactly opposite. It is exactly opposite. The gauge R and R's upper control, lower control limits are basically, calculated a little differently. Okay. Here, they calculated a little different control limits. They are very narrow control limits. And they are expecting less amount of data points here and more amount of data points beyond the control limits. Now, why? Because these data points are nothing but part to part variation. These data points represents part to part variation. And within the control limits, data points basically decide. Okay, for example, look at this. This is within control limit. This is within control limit. Or this is within control limit. This is within. There are only 4 data points are within that band of control limits. This is representing the variation because of the gauge R and R. And of course, there's a formula behind it. Again, let's not get into this and get confused. We want more data points going beyond control limits and less data points within the control limits. That is the desired state. Are you clear with this? Just type yes in the chat box. Are you clear with this? So in the first diagram, part to part should be highest, tallest. That is the desired state. In this X bar chart, more data points should be beyond control limit and less data points should be within control limit. This is the desired state. Clear? Yes. And remaining data points are, also, but these are a couple of factors which we need to basically check. Okay. So this is with the help of graphical representation, my gauge is doing fine as far as the graphs are concerned. Let me go back to the statistical part of it. To go there, I can go to this sessions window. You can see here a sessions folder. Okay. If you can open the sessions folder and scroll up, you will find this. Everybody go to sessions folder. Sessions folder is a folder where you will find all the statistical analysis being done. So you are doing graphical analysis. Whatever we have seen is a graphical analysis. Now we are going to the statistical analysis. Okay. With the gauge R and R, X bar R. Now you can see here. Everybody found this sessions folder. You can just click on this data. See over here, you can just see my cursor. This is 1, this is 2, and this is 3. Just observe these 3 tabs. The center wala tab is for the data sheet, data worksheet. So if you want to go to the basic data, click on this tab. If you want to check all the graphs, click on this tab. Okay. And if you want to go the statistical analysis, this is called the sessions folder. Okay. So if you click on that, all the statistical analysis will come in front of you. Clear? Are you clear with these 3 tabs? Just take a screenshot if you wish. The middle one is the data tab. On the right hand side, there's a graph symbol you can see. Okay, bar graph symbol you can see. And on the left hand side, there is a paper symbol is there. That paper symbol is sessions folder. Okay. Now let's come to this. Now here, only 3 factors we need to check. What are the 3 factors? Let's come to. So the 3 factors are, the first factor is, now look at this, gauge R and R contribution. and part to part. So part to part is contributing, in this case, part to part is contributing 97.64 percentage, and gauge R&R is contributing 2.36 percentage. So total you sum up at 100 percentage. Clear? इसका मतलब क्या है? Process variation is 97.64 and gauge variation is 2.36 percentage. So total contribution. So if this part is less than 10%, it is acceptable. This contribution percentage, if gauge R&R contribution percentage is less than 10%, it is acceptable. That's point number one. Then second factor we need to check is this percentage tolerance, this one. In this case also, it is showing 8.41. What is this? Percentage tolerance meaning? Percentage tolerance meaning? You remember? Upper and lower specification limit. Within upper and lower specification limit, whatever is the total variation, out of which 8.4% is because of the measurement system variation. This also the same funda is applicable. If it is less than 10%, it is acceptable. If it is more than that, then it needs some improvement. Okay. And the third one is called this NDC. NDC meaning number of distinct categories. Right now it is showing 9. This also should be greater than or equal to, understand this, it should be greater than or equal to 5. Either it should be 5 or greater than 5, 6, 7, 8, 9, etc. What is NDC? Just for our understanding, any, let's say any gauge, if you are having any gauge, okay, if that gauge is showing, let's say high and low, so that means number of distinct categories are 2 here. Understand this? If that gauge is showing high and low only, there are 2 distinct categories. That this is the only 2 categories we have in the gauge. Now, if you have, let's say, high, medium, and low, we have 3 categories. Distinct categories are 3. If we have, let's say, extremely high, medium, low, and extremely low, we have 5 number of distinct categories in the gauge. Are you understanding? So we can, what is the capability? What is the kind of, it's kind of a least count. Okay. And more is the least count or more is the distinct categories, better is for our gauge. Okay. Lesser the distinct categories, the gauge is not proper for us. So these 3 parameters we will check. Percentage contribution should be less than 10. Percentage tolerance should be less than 10. And number of distinct categories. There is a formula to calculate it. It should be 5 or greater than 5. Then this gauge is tested. Then whatever data we are collecting, then we can start analyzing that data. And this is called gauge R&R. Are you clear with this? Just give me yes in the chat box. Are you clear? Just give me yes. Super clear. Everybody got these numbers? Amazing. Awesome, guys. Awesome. Super. Now, with the same fundamental, let's check out the attribute agreement analysis. Okay. I've just shared a file with you called attribute agreement analysis. Just open this file. First, we will calculate it manually, and then we will calculate with the help of Minitab. Okay. Just download this file called AAA, attribute agreement analysis. Okay. Now remember, continuous data, gauge R&R, attribute or discrete data will go for attribute agreement analysis. Okay. So let me just close this file and open attribute agreement analysis file. Very good. Once you have opened it, let me know in the chat box. Okay. Open, done. Just give me done in the chat box. I just shared the file. Now in the chat, you will find a. Just click on in the chat. You can just click on the file. It will get downloaded. All right. Now just try to understand. Try to understand what is this data. Similar to our gauge R and R, here also we have got 10 samples. So in the C1 column, we have got 10 samples. But here we have got, instead of continuous data, there we were measuring some diameter, let's say. Here we are accepting or rejecting. No meaning rejection, Y meaning acceptance. Okay. So here officer 1, trial 1, officer 2, trial 2, officer A, trial 3. So officer A, officer B, officer C. There are 3 officers. Trial 1, trial 2, trial 3. So this data is there. Now only difference is that there is something called truth. Truth meaning the standard. For example, truth meaning the standard. There is no link for the file. Krishna, do you have Minitab downloaded on your laptop? Then only it will be working. Otherwise, it will not be able to open. You have Minitab with you? Krishna Sharma ji, do you have Minitab downloaded? Just give me yes, no. Okay. So very good. So this will be then only this will be. So can you see this file on your chat? I'm just sharing the file to everybody called AAA.mtw. MTW is Minitab worksheet. Just click on that file. It will get downloaded automatically. Are you able to do that? What is the challenge? Not able to click that? Okay. Do you have completed your green belt, Krishna ji, or you are very new in the system right now? No, there is no link required. There is only just file we are sharing. That's it. This file, there is no link. You're already in the room and we are just sharing the file in the chat. Okay. So have you completed your green belt certification? That's what my question. Yes, no? Hello? Okay. What I'll suggest, Krishna ji? Exam today. Okay. No issues. Okay. Just observe whatever. Let's say if you're not able to open it, let's observe this and then maybe you can practice it later. Okay. Let's observe what is happening here. All right. Now, kahan pe tha main? Truth. So truth is here. The truth is right now. Truth is somebody. Let's say this is a example of the credit department. Okay. And these samples are nothing but the loan files for the approval. They are reaching to these officers. And the truth is the credit manager, the credit head of the department. Okay. So everybody is saying no, 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 and he's saying no. So his ultimate word is final word. Okay. So this is also very important. Okay. This truth will check the accuracy of their reading basically. Okay. Now, let's measure the repeatability and reproducibility here. Let me explain you repeatability first, and then you can do it. Okay. For example, just observe first 3 columns here. This part, just focus on these 3 parts, 3 columns. Okay, everybody? Now, let's focus here. The first sample is saying no, no, no. That means he's repeatable with his reading, correct? Yes or no, everybody? Officer A in the first sample is repeatable. Yes or no? Everybody, he's repeatable. You remember the example, the definition of repeatability? The same person, same sample, giving the same reading is called repeatability. Correct? He's saying no, no, no. He's rejecting the file every time. That's mean he's repeatable. Correct? Second time, yes, 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 repeatable. Third time, no, 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 repeatable. Yes, 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 no, no, no. Yes. So if you see this, he is 100% repeatable. Yes, everybody? 100% repeatable. Can you check with officer number B and tell me what is the percentage of repeatability of officer number B? Type in the chat box. ऑफिसर बी का क्या है एंड देन ऑफिसर सी का क्या है? ऑफिसर बी, ऑफिसर ए इज 100%. वेरी गुड. Officer A 100%. What is Officer B and what is Officer C's percentage of repeatability? I'm talking about only repeatability. Officer B, if you observe closely, the last row, he's saying yes, yes, and no. So one mistake in the repeatability. So Officer B has got 90% repeatability. What about, yeah, so repeatability is 90%. What about Officer C? Yes. So Officer C, you can see the second one, there is a variation, and the second last one, there is a variation. So 80% repeatability. Everybody is clear with this? Just type yes in the chat box. So Officer A is 100%, Officer B is 90%, Officer C is 80%. So repeatability is 100, 90, and 80. Repeatability is measured individually. Clear, everybody? We are just doing it manually. Understand this? Correct? Super. Now let's find out the reproducibility. Let me remove this. So repeatability clear hai? Reproducibility, what is the reproducibility? Remember, you need multiple people. So the same file checked by multiple people. Even one person says a different reading, that means the reproducibility is failed. Okay, let's check out. See the first sample. See the first sample here. No, 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 no. So everybody is saying no. We are not considering the truth as of now. Okay, truth ko nahi dekh rahe hai, bro. So everybody is saying no. So this is reproducible. Correct? Second one, yes, 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 yes. But again, officer C is saying no, no. So this is failed. The third one, no, no, no. Again here, yes, yes, yes. So this is also failed. Again, the fourth one, yes, 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 yes. Everybody's saying yes. So this is passed. Okay, fourth one is passed. Fifth one is passed. Sixth one is passed. Seventh one is passed. Eighth one is also passed. What about ninth one? Ninth one has failed and the 10th one is also failed. So our reproducibility percentage is 60%. How many of you got it? Just type yes. Out of 10, we have got 60 reproducible readings and 4 failures. That's what 60%. Clear, everybody? So we have repeatability 100, 90, 80 for A, B, C respectively, and reproducibility number is 60%. Clear? Manual calculation. But do I have to do it manually every time? Answer is absolutely no. We have got our genie with us called Minitab. So what we do, we'll go to Minitab, go to Stat, Quality Tools, Attribute Agreement Analysis. Just click on that. Click on Attribute Agreement Analysis. Just follow this path. Stat, Quality Tools, Attribute Agreement Analysis. Okay. Once you click on that, this window will appear. Okay. Now here, because we have got multiple columns, just select this option called multiple columns. Just select multiple columns. Click in the center of this. All these columns will be over there. Okay, everybody with me? I'll repeat again. Go to Stat, Quality Tools, Attribute Agreement Analysis, AAA. Click on that. This will appear. Okay, so you have to select multiple columns because our data is arranged in the multiple columns. Okay, then click here. Now you have got sample officer A trial 1, officer A trial B, etc. Okay, so select officer A trial 1. Listen to me very carefully. Officer A trial 1, click on shift and select officer C trial 3. Everybody, I repeat again. Select officer A trial 1. Go to multiple columns. Okay. Select officer A trial 1. click on shift and officer C trial 3. So all these columns will get selected and click on select. All of them will get selected over there. Everybody got it? After that, number of appraisals, you can see 3 appraisals are there. Number of trials, again 3. And name of the appraisals, A, B, and C. And what is the known standard? Nothing but the truth. Select the truth. Okay, just follow this process. Officer A to officer C, you select all the columns in the multiple column segment. Number of appraisals 3. Number of trials 3. Name of the appraisals is optional. You can keep it blank as well, but I've just said ABC. And known standard is truth. And click on OK. You will get this graph first. Once you got it, just type yes in the chat box. Got it, everybody? Yes, 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 yes. Very good. Fantastic. So let's try to understand it. This is what is within appraisals. This is nothing but repeatability. You remember 100, 90, 80? The same thing. It is 100, second one at 90, third one at 80. The same showing. What is appraisal versus standard? It is repeatability, but this is accuracy of repeatability. What is accuracy of repeatability? What is that? It is the comparison with the standard, with the truth, which means the first person was not only repeatable with himself, but 100% repeatable with the truth as well. When he was saying yes, 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 the truth, the standard was also saying yes. When he was saying no, 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 the standard was also saying no. Are you clear with this accuracy? See here, this is only between themselves. This is with the comparison with the standard called truth. Clear hai? Just give me yes in the chat box. So in that comparison, the first one is 100% accurate. The second and the third one is 80% accurate. Clear? This is just type yes in the chat box. Super clear, everybody. Just give me yes. समझ में आ गया है कुछ? Any doubt, any question, you can let me know in the chat box. All right. Now let's go back to the statistical part. What do you want me to repeat? Okay, let me repeat once again. Have you got this graph first of all? Have you got this graph? Kelly TG, have you got this graph first of all? Have you followed the process and got the graph? Data graph not seen, is it? Okay. So have you received this? So let me just quickly go to the data. Have you received the data file first of all? Have you received the data file? Yes. Okay. Now what you need to do is go to stat, quality tools, attribute agreement analysis. Okay. Click on that. Select multiple columns. Let me just do it. Select multiple columns. Here in after multiple select columns, select officer 1, trial 1, shift, officer C, trial 3, and click on select. It will get selected on the right hand side. After that, number of appraiser 3, number of trial 3, and you can put it other things blank. Just put truth over there. Okay, ABC लिखने का जरूरत नहीं है. Is no need to do that. Just put known standard to be truth. Okay, truth is a column there. Double click on column, it will get selected, and then say okay. Then click on OK. You will get this graph. Clear? Now in this graph, what is happening is We have calculated manually repeatability. The first one is 100%, second one is 90%, third one is 80%. The same thing is there. This is called repeatability graph. And this is the accuracy of repeatability comparison with the truth. What it is showing is the first person is 100% repeatable with the truth as well. And other two people are 80% repeatable with the truth. So out of 100 times, 80 times, they are exactly matching with the truth. 20% of the time, they are making some errors. Clear? So this is how this graph can be read. What is more important for us is the next part, which is nothing but this, our sessions folder. Okay, just click on the sessions folder and just scroll it up. Once you, click on the sessions folder, you need to scroll it up. There are a lot of statistics are there. Okay. We need not to go deeper into that. I can explain you this, but I will quickly touch upon the main part of this. If you see here, this one is within appraisal. Okay. Again, you can see 100%, 90%, 80%. This is nothing but repeatability. Okay. Which we have already seen. Then this is something very, very important, which is called fleece kappa statistic. Okay. Where in the GRR, we saw GRR value, right? Here we are seeing the fleece kappa statistic. Okay. Which fleece kappa statistics is most important? Now we will come to know this. So the first is repeatability. The second one is accuracy of repeatability, which is 180-80, which we have seen in the graph. Okay. Let me scroll it a little. If you scroll down, you will find the most important. If you scroll at the bottom, okay, this is what we are looking at. Understand this. This value, the fleece kappa statistics value, this is what we are looking at. This one. Oops. Yeah, this one. Okay. Which is showing 0.7828, something like that. Everybody got this value? 0.7828 fleece kappa value. Okay. Now with this fleece kappa value, if your fleece kappa value is between 1 to 0.9, you have got the best fleece kappa value. You have got the best, what you can say, measurement system. If it is between 0.9 to 0.7, okay, still acceptable. If it is less than 0.7, then you need improvement. You need to give training to the people, etc., etc., etc. Okay. So in this case, it is less than 0.9, but still it is acceptable because this is between 0.7 to 0.9. So it is in the acceptable range. Are you clear with this? Just type yes in the chat box. This is called the AAA, Attribute Agreement Analysis. Clear? So this overall exercise is called as measurement system analysis, which is not there in the green belt level. It is there, but just the introductory part. Not this practical, not Minitab is not there. Okay. In the black belt level, we go deeper. We go practical. We go how to create the worksheet, how to collect the data, how to analyze the data to the deep level. This is what we check. Clear, everybody? Just type yes in the chat box. Super clear hai? Yes, 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 yes. Very good, very good. Now, kappa is the name of a statistician. Fleece kappa. Fleece kappa is the name of a statistician. See, these statisticians give their own name. Okay. Like, for example, Anderson-Darling normality test. Like Theodore Anderson, Donald Darling. They are statisticians. So they give their own name. So they find out any test and they give their own name to the test, so that their name also can be get attached to that, their discovery. Okay. Anyway, so on this note, it is 8:30 p.m. We will take a small break of 10 minutes. Okay. Yeah. So all the automotive use this kappa value, in this gauge R&R AAA study. Okay. Super. So what we'll do is we will take a break for 10 minutes. and we will be back exactly at 8:40 p.m. We have some other portion to cover. Today, we are going to cover the normality testing and how to handle the non-normal data. Okay, what is the transformation theory? Okay, that is something which we are going to cover, and then process capability. Okay, clear? Yes. So we'll be back at 8:40 p.m. sharp. Till the time, enjoy yourself, stretch yourself, go to, take a bio break, grab a cup of coffee or tea, and come back at 8:40 sharp. Okay, I'll see you on the other side. Okay, all right. Are you back, guys? Just like I'm back in the chat box so that we can start the session. Superb. I hope everybody's back on their own seat. Just give me a confirmation quickly. Chalo, fatafat confirmation. Very good, very good, very good. Amazing. Chalo. So what have we seen right from 7 p.m.? Thank you very much, Madhuji. Thank you very much. Superb. Okay, चलो let's quick recap करते हैं. Then आगे बढ़ते हैं because very important topic I'm going to cover, which is the transformation of the data. Okay, which is very important for the black belt people. All right. Yes. So what have we covered? Just type in the chat box quickly. Let me see how many of you remember. Okay. So first we started with how to generate a data in Minitab, right? You remember calc, random, normal. Remember that. Calc, random data, normal. Okay, that sequence. Remember that. Once you click that, you can generate n number of data points, 50, 550. Then we generated histogram and central limit theorem, CLT. Correct? After that, what we have seen? After CLT, yes, we have discussed that in the defined phase of green belt, black belt, there is no difference. So same hai. Okay. Then we have seen the green belt and black belt ka difference. In the whiteboard, I explain you what is the difference between green belt and black belt. Correct? What else we have seen? MSA, measurement system analysis. So there are two parts of MSA, which is gauge R&R in continuous data, discrete data, AAA. Correct? So how to generate, how to create the worksheet of gauge R&R. First, we understood the theory behind it. So AIAG, VDA, okay, guidelines, which is 10 samples, 3 trials and 3 people, correct? Total 90 samples. Then how to collect the data, how to put that in the software, what, how to check the graphs, what data to be checked. That was, we have seen, correct? So we have seen gauge R&R and AAA, correct? Yes. Now let's go ahead and discuss about transformation. Yeah. Meanwhile, I think KLTG, we have green belt classes on Saturdays and Mondays. We have the live classes, and similar to the hackathon will happen in the month of May 1st week. Okay, we'll have a green belt. So because you have just recently joined in, you can complete this green belt course and attend the hackathon just like what we are doing for the black belt. Okay, in the next month. All right. So that will be a complete. So within 1 month, you can complete your green belt curriculum and certification examination as well. Okay. You can do it faster as well, but this is the logical or natural flow you can go with. Chalo, so let me share a whiteboard right now. So the topic which we are discussing right now, it's called, see, one of the major objective of major phase is to check process capability. Process capability. Okay. And what is process capability? When we say, my process is 5 sigma process, my process is 4 sigma process, or my process is 6 sigma process, that number, that 5, 4, 3, 2, that number is nothing but a process capability number. And that process, what you can say, that number we need to check. And that checking of the number, it's called as process capability analysis. Okay. And in the process, before we do the process capability analysis, there is one thing which we do. It's called normality checking. Normality test. Okay. And which is also called as Anderson-Darling normality test or AD test. Again, Anderson-Darling are two statisticians who basically discovered this test, Theodore Anderson and Donald Darling. Okay. So that's why it is called as Anderson-Darling normality test or AD test. Okay. Now, once the data is normal, then we go for the process capability analysis. And how do we do the normality test? Let's generate this data. Let's open the same Minitab file which we have just done. Okay, same Minitab file we can open. Any Minitab file, by the way. Okay, let's open any Minitab file. Okay, any Minitab file open karo. Now we will generate some data in this column called C12. Okay, let's generate 30 data points. Let's go to calc, random data, normal, the same data generation. Okay, let's generate 30 data points in C12 column. C12 because its column is what you can say empty. Okay, say okay. So now I have got 30 data points in the C12 column. Everybody just do this. Just open any worksheet, generate some data, and now we will do the normality test. So how do we do the normality test? Go to stat, basic statistics, and the third last option is called normality test. Stat, basic statistics, normality test. Okay. Once we select the normality test, just select the variable column C12, which is column 12, and say okay. And you will find this kind of plot. Everybody got this kind of plot. Of course, your numbers will be different. Your values will be different. But have you found similar kind of plot? Just type yes, no in the chat box. Have you found similar kind of plot? Just type yes, no. I'll repeat. You open any Minitab worksheet, and generate data. Okay. Yeah, Devdaji, if you are done with this, let me know. Once you have developed 30, 50, 100 data points, let me know. You can generate a number. Okay, 30. Okay, have done generated. Very good. Now you go to stat, basic statistics, normality. Just see the flow. Stat, basic statistics, normality test. Okay. Once you click on that, just select the C12 in the variable. Now, in my column, it is C12. Whichever column you have selected, you got to select that column. And just click on OK. That's it. Don't do anything else. Once you click on OK, you will find this plot, which is called normal probability plot. Done. Now, in this case, what is the most important? Very good. What is the most important here is, see, this is the data, C12 column mein jo data hai, that is there. This is the percentile of that data, percentile, which we cover in the green belt level as well. What is the most important is p-value, this value. If your p-value is greater than 0.05, the data is normally distributed. If the p-value is greater than 0.05, the data is normally distributed. So, in this case, the data is normally distributed. Are you understanding? This means the data is normally distributed. I can plot a histogram and check this as well. Let's plot a histogram. So, histogram में भी कुछ पता चलता है, okay, graphically, whether the data is normally distributed. Just C12, okay. So, you can see some symmetrical distribution as well. Clear? So, whenever your data is showing p-value greater than 0.05, that is normally distributed. Oh, see, what is ovality? This one you are saying? This one, right? Still it is symmetrical. Majorly, the mean, mode, median are, in the, in the center. In that case, it is called a normal distribution data. Now, see, there is something called perfect normal distribution. something called perfect normal distribution, something called, normal distribution. Okay. In normal distribution, there is some kind of skewness also is there. Some kind of skewness. Okay. In diameter, ovality is non-normal distribution. No, see, it's like if you are checking the ovality. Let's say if you are checking the ovality and you put that ovality data in the histogram, what kind of distribution you are observing? Okay. If you collect the data of oval, let's say there is a cam. Okay, there is a cam you have, and you want to check the ovality of the cam. Okay, now you have the data collected of the cam. Put that data in the Minitab software. Check the histogram. See whether it is normally distributed or not. Check करके देखिए एक बार. All right. Clear? So see, understand it. So once we have the data in this, and if it is normally distributed or symmetrically distributed, graphically you will get a sense of it. But with this plot, normality plot, with this p-value, it's a statistical confirmation that it is confirmed this is normal distributed data. Okay. Now, but what happens? Sometimes we get non-normal data as well. Just download this file which I'm sharing with you. ये file को download करिए. Let's discuss about non-normal distribution data. Okay. Let me. Yes, can you just open this file? The name of the file is called log distribution. See, in the green belt level, we already have studied how to check the normality of the data, how to check the process capability. But here, there is a twist in the tail. Every time, we don't get the normal distributed data. Everybody open the file here. Once you open the file, let me know open. Let you open the file. Very good. Now understand this. Huh? This is the file called time. The C2 column is called time. So we have got some time data here, some processes they have done. And this is the data of the time here. Okay. All right. Now what we are going to do is, we are going to check whether this data is normally distributed or not. The same procedure we need to follow. Go to stat basic statistic. Or first we will make a graph. First we will make a histogram. Okay. Histogram करके देखो इसका. Select the time column. Say okay. If you observe very closely, this is not symmetrical distribution. This is kind of a skewed distribution. This is called right hand side skewed distribution. Are you understanding this? Just give me yes in the chat box. So graphically also you can check this kind of a skewed distribution. Everybody got it? Just type yes, no in the chat box. Just make a histogram out of it and check the skewness of this. You will find, you will, with your naked eyes also, you can observe there is a skewness in the data. And here the secret. Whenever you are dealing with a time related data, listen to me very carefully. Huh? Whenever you are handling time related data, majority of the time you will observe skewness. Now, what is time related data? You have delivery time, you have downtime, you have cycle time, processing time. Whenever you are having data of time, you will, majority of the time, you will see kind of, let's say, pizza delivery. You collect full day's delivery time data, you will find some kind of skewness over there. Are you understanding? Yes? All right. This is just one clue I'm giving you out of my experience. All right. Now, how do we deal with this situation? When we have these kinds of, okay. Now, if I put, upper and lower specification limit like this, okay, I will not get the right picture because on one side, I will have more defect. On other side, I will have no or less defect. So I will not get the right process capability. That is the reason what we do is, whenever we get to know similar kind of data, okay, let's do the normality test as well. Go to stat, basic statistics, normality test. ये भी करके देखो. Stat, basic statistics, normality test. Select time data here and say okay. And look at the p-value less than 0.0005 or 005. Everybody got it? Go to stat, basic statistics, normality test. Put time column in the variable. Click on OK. And you will get it. P-value less than 0.05. That means it is an indication that it's a non-normal distribution. Now, whenever you come across non-normal distribution, now this is a smart question. Let me see how many people can give this answer. We have understood CLT, central limit theorem, in the beginning of the session itself. If I come across non-normal distribution, what do I do first? Type in the chat box. What can I do? Very good. You increase the sample size and check again. Are you understanding? Yes? You increase the sample size and check again. That more the sample, by default, it can get the normal distribution. Sometimes, when you have the time-related data, sometimes it even does not get the normal distribution. Okay, it's like, when we have some disease, we go to a general physician, doctor. First, doctor gives us some medication. Okay, some दवाइयाँ दे के doctor check करता है कि कुछ improvement है क्या. Even if it is not, then he may change that. Or even if it is not, then he will go for the operation or something like that. Similarly, whenever you come across non-normal distribution, increase the sample size. That's point number one. Even if it is not happening, then we go something called as transformation. What is that? Transformation of the data. What is transformation of the data? Transformation of the data meaning representing or presenting the data in a different way. Presenting the data in a different way. It's called transformation of the data. Yes, very good. Kilometer to centimeter, or something like that. All right. Now, during our schools and college days, we used to basically use, if you remember, log tables. How many of you remember log tables? कितने लोगों को याद है log tables? Do you remember log tables? Yes. A lot of people must be remembering this, huh? Yes. Yes. What is log table, by the way? Log hota kya tha? What was log, by the way? How many of you remember log? We don't remember that, right? Majority of us don't remember that. Yes? Correct. Scary subject. That's what I always say. The statistics was not taught to us, the way mathematics, statistics, the way it should have been taught. That's the way people still have the fear and, doubt, etc., etc. Anyway, let me just open one very important document. Yes. Okay, yes. Now, what do we do in this kind of scenario? Let me just, kahan pe hu main? Just do it once again. Whenever we come across this, okay, there is something called, before I go to log, etc., okay, logarithm, yes. If I come across this kind of non-normal distribution, there is something called transformation. Even after sample increase, we are not getting data normal. Then we can go for transformation. Where do we find transformation? Okay. We go to stat control chart, and there is something called box-Cox transformation. Just select that. Go to stat control chart, box-Cox transformation. See, if you are very new, you find it a little difficult because you have not been through this a single time. Okay. But if you have gone through the black belt content, it will be an easy peasy job for you. Okay. Just observe this stat control chart, box-Cox transformation. Just click on that. Now here, you have to select the time column. Subgroup size, just select 1, and say OK. Okay, you will find this kind of graph. Let's not get into the detail. What we are interested in, this value. This value is called lambda value. Lambda. Again, lambda is a Greek letter, just like sigma, delta, alpha, beta, theta. Okay, lambda is also Greek letter. So lambda is showing 0 value here. Okay, just keep this value in mind. Everybody got this value? Just give me yes, no in the chat box. Or shall I repeat this? सबको मिली ये value? Okay, I repeat this. Yeah. Go to stat, control charts, box Cox transformation. Stat, control chart, box Cox transformation. Okay, इस पे जाइए. Yeah, रमेश जी just हे follow करा. Stat, control chart, box Cox transformation follow करा. Done. Once you click on that box Cox transformation, you will come to this page, this window. यहाँ पे just put time and subgroup size 1 and just click on OK. That's it. Select double click on time column. Just subgroup size 1. Subgroup meaning these are individual samples. That's it. There is no group of samples we are taking. If we would have taken group of samples, that number of groups we have taken. Okay, 10 samples, 5 samples, etc. Right now, just put 1 and click on OK. And you will find this value, this graph. What we are observing here is the rounded value is 0. Lambda value is 0. Now, what do we do with that? Okay, let me show you a table which is also given in your black belt curriculum. It is also there in the transformation segment, data transformation. This table has been given. Let me just quickly cover this. Now, here in the first column, you can find the lambda value. Okay. Now, we are getting lambda value 0, right? So, what it is suggesting to give a log transformation. When lambda value is 0, whichever data set you are having, just take a log value of that. Now, what is log value? Let me just explain you. Example. Okay. Let me take a white one. Let's say, understand this, huh? 10 raised to 1. Okay. So, understand this is equal to 10. Correct? 10 to the power 1 is equal to 10. Right? So, log of 10 to the power 1 is equal to 1. Log of 10 to the base 10. Let's say 10 to the base 10 square is equal to 100, correct? So log of 100 is equal to 2. 10 to the power 3 is equal to 1000. So log of 1000 is equal to 3. How many of you got this? Just type yes in the chat box. Just simple. How many of you got it? Yes? So 10 to the power 1 is equal to 1. 10 raised to 1 is equal to 1. 10 raised to 2, meaning 10 square is equal to 100. So log of 100 is equal to 2. Log of 1000 equal to 3. You got the point? So if you have 10 value, it will say 1. If you have the value, the original value of 100, instead of 100, it will take 2. If your original value is 1000, it will take 3. And in between. This is called the log transformation. Similarly, let's say whenever my lambda value is 0.5, I will take the square root of the value. Then it will get transformed. Whenever my lambda value is 1, I don't have to transform anything. No transformation is required. When lambda value is 2, I will take the square value is that. Similarly, on the lower side, my lambda value is minus 0.5. I will take reciprocal of the square root. If my lambda value is minus 1, I will take the reciprocal of the value. So similarly, there is a table. Are you clear? And lambda values are basically between minus 5 to plus 5. इतने रेंज में लैम्डा वैल्यूज रहते हैं. नाउ minus 5 मतलब, for example, if lambda is minus 2, it will be 1 raised to y square. If lambda value is -3, sorry, 1 divided by y cube. When lambda value is -4, it is 1 divided by y raised to 4. When lambda value is -5, 1 divided by y raised to 5, etc. Clear everybody? Just type yes in the chat box. ये समझ में आया? log transformation. Okay, this table is given in your. Now coming back to the same data. Okay, this one, right? Pibu Dattaji, this one you want to, right? This is the rounded value, which is the lambda value. This we have to check. If this is 0, then according to the transformation suggested, we have to follow this. Okay. Now let's go back to the data. Now we wanted a log transformation, right? So what we will do is, in the C column, we will give the name called log transformation. Now, why is that this number? Why is this number? This number. If y is 0, take the log value of this. That's what it means. Clear? Okay. So let's convert this into log. Now, how do we convert this into log? There is a simple way of doing this. Go to calc. Go to calc. Open the calculator. The first option is calculator. Open the calculator. Okay. This calculator will open. Everybody? Now here it shows store result in variable. Now here we have to store the result in the log column. So double click on log, it will get selected. Follow this. I repeat again, go to calc and the first option is calculator. Open that. Store result in variable log. Now in expression, here there are multiple expressions. The functions are there. Okay. You select logarithmic function because we want to convert into log, right? Select logarithmic. Okay. And log base 10. So here I will just double click. See here in function, if you drop down this, you will see logical, statistical, text function, trigonometry, etc. Just select logarithm and select log base 10. Okay. Just double click on that. When you double click in the expression space, it will log 10 in bracket. There is called number. Now what you need to do is, which column you need to convert? It's a time column, right? Just double click on time. Okay. Now listen to me very carefully. I repeat this entire step once again. Okay. Listen to me very carefully. So this is there like this. Go to calculator. Store the variable in log. So log में select करना है. In function, I will just go to drop down, select logarithm. In logarithm, I will say the first option, log to the base. I'll double click on that. And I will double click on time. And I will say okay. And here what we have done is, we have converted this entire data set into a logarithmic data set. Just for our understanding, if you see here, any 100 data, 100 ka log kya tha? 2. You remember? If you see here, 100 data is there, the log value is 2. Can you see this column? You know, row number 24. The original value is 100, but the log value is 2. Are you getting this? Just type yes in the chat box. Clear hai everybody? Very nice. Very nice. Super. Amazing. Super. Now we need to check the process capable because now we have transformed. Now let's check this log value, whether this log value is normally distributed or not. Okay. Isko normally distributed hai ki nahi check karte hai. First, you select the histogram. Histogram karo. Log value ka histogram karo. Instead of time, select log. Say okay. Wow, look at this. Can you see here the difference? Okay, or rather than दोनों का भी हम लोग करेंगे. दोनों का भी करेंगे. Let's do it together for both log and time both. Okay, log ko bhi karo, time ka bhi karo, just okay. So both these histograms are there. Can you see here? The earlier histogram was a skewed distribution. This histogram is symmetrical distribution. Can you see the difference graphically? Just give me yes in the chat box. Can you see a graphical difference between these two data sets now? Are you understanding this? Correct? Fantastic. Superb. Now what we do is we will have to convert. Okay. Let's say our lower specification. Let's say now we have to do the process capability. Why we are not able to get the p value? Okay, p value नहीं मिल रहा है उसका. Let me check. Basic statistics normality test. इसका p value मिलना तो चाहिए. Let me see. हाँ मिला ना p value. Log का p value देखिए 0.299. It's greater than 0.05, right? Okay, इसका p value भी चेक करो. हाँ हिस्टोग्राम में नहीं मिलेगा ना. हिस्टोग्राम में जैसा ग्राफिकल रिप्रेजेंटेशन, राइट? This is the statistical confirmation. Yeah, everybody, after this histogram, just check the normality test as well. Okay, go to stat basic statistic normality test. करके देखो. Select the log value and you will get p value greater than. Earlier p value was less than 0.005. Now it is greater than 0.005. It is 0.299. So it's a confirmation that data has been transformed to normal distribution. Now we are ready to do this process capability analysis. What is process capability analysis? We will put this data, we'll put the upper specification and lower specification limit. Let's say lower specification limit is 50 and upper specification limit is, let's say, 400. So LSL is 50 and USL is 400. Okay. So 50 का value है this. 400 लेके कुछ और ले. Yes, I think 300 लेते हैं क्या? हाँ चलेगा, 300 लेते चलो. So let's say 300 instead of 400. Let's take 300. Okay. So 50 का actually, so this is actual value. And what is the log value of 50? You can see here 1.6989. Okay. We can use of log. Yeah, exactly. Now 300 का क्या है log value? You can see here 2.47712. 2.47712. Everybody got this? So instead of actual values, I have taken the log values. Clear? To find out the process capability. So we will check what is the process capability of this. Okay, let's find it out. Let me clear this. So how do we find out? Go to stat, quality tools, capability analysis, and normal. Because we have converted to normal distribution, we can select normal distribution here. Quality tools, capability analysis, normal. Stat, quality tools, capability analysis, normal. Just select this. Click on that. Now here, understand this. In the single column, you need to select the log value. Select the log value. Okay. Subgroup size is 1. Lower specification limit, you have to put the log value here. Okay. Lower specification क्या है? 1.69897. Okay. Which is the log value of 50. And upper value, upper spec is 300, right? So what is the 300? 2.47712. 2.47712. Okay, everybody with me? Now, once you put this specification limit, which is converted into log, go to option and select benchmark Z. Select benchmark Z. Go to option. Option is available on the right hand side. Third option, third button. Go to option, select benchmark Z, click on OK and click on OK. And you have got this value. Okay. So right now your process capability is your process capability is 0.78. That means this process is 0.78 sigma process. This is the values, the Z bench value you have to select. So right now this process is 0.78 sigma process. Are you clear with this? Just type yes in the chat box. Are you clear? Got this value? So this way, whenever you come across a non-normal distribution, then you have to convert that into normal distribution first by increasing the sample size, and then if it is not getting converted, you can transform the data with the Box-Cox transformation lambda value. Okay, so this process we have selected. Okay, what is Z value? See, Z is nothing but process capability value. Z is nothing but process capability value. Okay, process capability. Now, when we say 6 sigma, this sixth number is nothing but this Z value. More that Z value, better is our process. Right now, when our process is 0.7, it is very poor process. This process requires improvement. Okay, you can see a lot of data points going beyond the specification limit. So we want a process which fits exactly in this. So as the process shrinks, it fits in the upper and lower specification limit, and the Z score increases. Are you understanding this? And this is how the Z score basically tells us what is our process capability. Clear hai everybody? Just type yes in the chat box. How to fix CP? We cannot fix CP. We can fix CPK. CP is the potential. CPK is the actual. CPK is the maximum. Okay. So CP is what? CP is the potential process capability of your process. And CPK is actual. In CPK, we have to shrink the variation, reduce the variation, and hit the center. That's why the definition of quality in Six Sigma is reduce the variation and hitting the target. Hitting the target plus reduce the variation, then you can achieve your Six Sigma level of performance. All right. And how do we do that? Just answer this question. It is like, for example, once you have this, once you do this process capability, then we ask this question, why? Then man, machine, method, mother nature, all these kinds of causes will come. And then we will work on one by one to get this. Okay. CPK is process capability. See, CPK is the short-term process capability. PPK is a long-term process capability. That's the only difference. Okay. It's like, you know, in the, what you can say, in the share market, there is, you know, intraday variation of the share, that is called CPK. Okay. CPK is a measure of that process capability within that short span of time. And PPK is over the long 1 year. Let's say that is called a long-term process capability. That will be a PPK. Okay. No, now it depends on process to process. It depends on process to process. Process capability depends. Let's say, for example, understand this. Short-term and long-term cannot be defined in months or year. Let me give you an example. Short-term, long-term meaning. Let's understand the long-term. Long-term meaning. This is very deep question what Devdas has asked. How do you define short-term and how do you define long-term? Long-term encompasses all the variation factors. Understand this. For example, let me give you a classic example of cold drink. In the cold drink business, now we have, let's say, yearly cycles, right? In the cold drink business, their sale naturally goes up during the summer season. Naturally goes down in the winter season. Yes or no? As far as India is concerned. Okay. In the summer season, because the temperature, humidity goes up, so a lot of people consume the cold drink and the drinks basically. So if you want to understand the cycle, the long term will be 1 year for them. Are you understanding? So long-term meaning it should encompass all the variation which are coming in this entire system. What is short-term? Short-term it can be 1 month, it can be 1 week, it can be one shift data, it can be 1 hour data according to your process. So short term can be anything. You take a sample, that becomes a short term process capability. You take a sample of 50, you take a sample of 30, it is short term. But long term should encompass all the variations. Clear hai? So long term process capability, if you collect 1 year data, that will be PPK. If I collect 30 data samples, that will be CPK. Correct? If you have 1 year, 2 years, 6 years, 5 years data, go for PPK. That's a long-term process capability index, and short-term process capability is CPK. Clear? Hai? Very good. Good questions, by the way. Super. Chalo. So is it done? Clear hai? Yahan tak everything is clear? How many of you are feeling bheja fry? All the new members. New members, how many of you are feeling bheja fry right now? Honestly, tell me yes in the chat box. How many are feeling bheja fry? अरे क्या है ये, इतना सीखना पड़ेगा? ये तो यार येलो बेल्ट में कितना सिंपल लग रहा था, अभी तो बहुत कॉम्प्लेक्स लग रहा है. हाउ मेनी ऑफ यू आर लाइक दैट, लाइक इन सबकॉन्शियस माइंड ये सब पढ़ना पड़ेगा क्या? सी आई टेल यू वन थिंग, आई टेल यू वन थिंग. once you go through this once or twice now, it will be all repetition. Okay, it will be very easy peasy for you. Why you are struggling? Because this is the first time you are observing, you are uncomfortable. Whenever we are uncomfortable, we are learning something new. Do you remember your first day of driving your car? How many of you remember driving your car first day or your bike first day? You were so confused. अरे मैं steering पे ध्यान दूं, सामने देखूं, clutch, gear, my mirrors, handbrake, and there are so many variables. Then accelerator, brake, clutch, ABC, gear 1, 2, 3, 4. My God, it's confusion. That is the best time you learn driving. This is the same procedure happening right now. Okay. So don't worry, give time some time. Okay. Be relaxed. Just go with the flow. Right now, this is the black belt hackathon. Okay. This is not for the new members right now, but I invited you especially to experience this. Okay. Once you go through the green belt and you go through the black belt curriculum, then all the dots will start connecting one by one. And then you will realize, okay, that's what it means. Okay. Everything is same. Everything is circle, PDCA, DMAC framework. Clear hai? Only thing is that you need to practice, 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 and practice. So what we'll do, without further bheja fry, we will stop today. We will continue going in the next phases of black belt. Okay, because I don't want you guys to. Today was a working day. I know that you guys are tired, etc. Okay, so we'll stop here. We'll connect again at 7 p.m. tomorrow sharp with the next topics, which will be even more interesting. Okay, we'll go for advanced hypothesis testing tomorrow. Okay, chalo, bye bye. Take care. Thank you very much. This recording will be available in the Black Belt Hackathon section with the files as well. You can check out the file and practice yourself. Okay. Yes. Till the time. Goodbye. Take care. Keep learning. Keep growing. This is Dinesh Patil.